short column, and we have another one called long column. Sometimes we can call it slender column. Short column, first case, we have only P ultimate only, without moment or with or without eccentricity, E, or with very small eccentricity can be neglected. This case, we need to figure out your column is tied column or spiral column. But please make sure the moment is neglected or we don't have moment. How can I know the eccentricity is small or big? This eccentricity smaller than 0.1 h or smaller than 0.05 h. What is the h? You have a column. We have P and we have h. If this eccentricity, which is given, smaller than 0.1, 10% of this h, neglect it. Forget that you have a moment. In the case of tied column. In the case of a spiral column, if this eccentricity is smaller than 0.05 h, forget it. Just to focus on P ultimate. And we have two equations to design this column. Tied column and one for spiral column. Second case. I'm still talking about short column. Second case. We have P ultimate and M ultimate. Or we have P ultimate and eccentricity. And this eccentricity cannot be neglected. You have to consider it. If this eccentricity smaller than 0.1 h, forget it. Neglect it. If this, in case of tied, in case of spiral column, if this eccentricity is smaller than 0.05 h, forget it. And we are in this case. I believe this is the first time to mention this. Or second case, if you have a P ultimate and moment, or we have P ultimate and eccentricity. This eccentricity cannot be neglected. Then we are going to use something called interaction diagram to figure out the value of rho, which equal area steel divide B time H or time T, whatever. And we learned last week, how to use interaction diagram. Guys, the meaning of eccentricity, just to make sure you are figuring this out. Here is the column. What is the meaning of eccentricity? This column has a centroid. If the applied force for any reason is not concentric, so this P ultimate has eccentricity from the centroid. This is the meaning of eccentricity. This eccentricity will cause moment. And the relationship between this moment and this P ultimate, M ultimate equal P ultimate time eccentricity. Force time distance equal moment. Any question so far? Guys, do you have any questions so far? I covered this case, P ultimate and any moment or any eccentricity neglected. We have two equations based on the type of column, tight column or spiral column. The second case, whatever. I don't care. Don't care if you have a spiral or you are tight. I don't care. Doesn't make any difference if you are in the case of interaction diagram. We don't care. So we can use interaction diagram for few steps. We learned these steps last meeting or last week, and we can figure out finally the value of rho centricity ratio. Reinforcement ratio, and then we can figure out the value of area steel. Okay. Today, I'm gonna talk about long column. For any reason, for some reason, we need to make our column long a little bit. I'm sorry, what you mean by long column? How can I figure out between long and the short? Do you remember I covered this before? If your frame is non-sway, we don't have effect of earthquake or something like this, so the frame will not swaying. So if you get K times L divide R smaller than or equal 34 minus 12 M1 divide M2. If this condition is satisfied, your column is short. So I am in this side. You need to figure out, do you have a moment or not? Do you have eccentricity or can be neglected to figure out case 1 or case 2? But if this condition not satisfied, K times L divide R not smaller than or equal, it's greater than. That means your column is long. So right now we are in the other side, long column or cylinder column. Just to remind you guys, K is a factor. Do you remember? Your column is hinged, or fixed, or fixed free, or fixed hinged, or whatever. L, U, and supported length, K times L, U called effective length of the column. Go back to the previous week. You can find all of this stuff. R, radius of gyration. We can figure out the radius of gyration accurately using this one. Square root of area gross divide area, moment of inertia divide area. Or 0.3 times the side, one side, which is H of the rectangular column, or 0.25 times diameter of this column if the column is circular column. So first step before starting to design your column, you have to decide if your column is short or your column is long. If the problem did not say, if the problem didn't say for the shown short column or for the shown long column, please, you have to check. You have to check. This column is long or short based on this expression. Any question so far? Looks good. Looks good. Okay. If the column under the effect of buckling, we have a big issue. Do you know why? I will let you know. If this column does not subject it to buckling, and you have applied force here, can you tell me what is the moment here? What is the moment due to this force, P? Do you remember any moment? equal force time distance. That's fine. And your force and this distance must be perpendicular. What you mean? I mean, you are taking the moment at M at this point due to the effect of force P. So we have a force. This force is a vertical force. Do you have horizontal distance? If the column does not buckle, no, we don't have distance. So this moment equals 0. We don't have distance because this force passing through this point. We don't have distance, so we don't have moment. After buckling, if buckling started, this point became here. And the applied force at the same location here. Do you have moment? Yes, I think. If you multiply this force by this lateral distance due to the effect of buckling, we can expect moment. This moment will make this column weaker because failure will happen early. So, did you get the meaning behind buckling? Buckling will create moment. In the real life, in the normal philosophy of a column, if the load passing through the column, we don't have moment. But after buckling occur, we have a value of moment due to this lateral distance. So if you apply this force by this lateral distance, you have a moment. Any comment? That makes sense. So buckling long column is weaker than short column. Long column is weaker than short column. Can you watch this experiment? We have a column here under the effect of buckling. This applied force will have this distance, lateral distance. So if you apply this force by this distance, you can expect a moment. So at this location, we have M ultimate and B ultimate. However, if this column still without buckling, we have only B ultimate only at this location. That makes sense? Okay. Okay. Empty slide. I'm gonna do many things here. We have different cases for a column. The first case, I'm talking about long column. How can I decide this column is long? You should decide this before, after you check this relationship. So you told me, hey, this column is long column. We have different case. The first case, this column is a part of a frame. So we have a moment here. And we have another moment here. Looks like this. Just to remind you for something you learned it before in structure analysis. Do you remember in structure analysis, we talked before about something called frames? Probably this column is a part of a frame. We have fixed. We have a roller. Probably we have hinge here, not here. This one will be unstable. Here. So we have load for any reason. So after you are drawing bending moment diagram, we can expect a moment on this beam or on this column looks like this. So this column will have moment M1 and M2, not equal, but on the same side. And also we have axial force, P ultimate. So right now we have moment and we have P ultimate. If you have this case, M1 will be the smallest value, and M2 will be the bigger one. M1 and M2 will be both of them positive value. Second case, probably your column, for any reason, we have a moment here, and the moment at the other end will be on the other side. So your moment looks like this sometimes. By the way, the first one will be single curvature. Your column will buckle like this. This column will buckle like this. This is the shape of the buckling. Single curvature. The second one, we have M1 and we have M2. Guys, M1 is the smallest value, because one of you will say, hey, which one is M1, the lower one or the upper one? I don't care, this one or this one. My concern is M1 is the smallest value and M2 is the bigger one or the biggest one. M1 is just a second. M1 will be negative, M2 will be positive. This case called double curvature. What you mean by double curvature? I mean this column will buckle like this. Due to the effect, we have a moment here and we have another moment on the other side, so the curvature will not be single curvature, because we have moment on different sides. So your buckling will be double curvature. In this location, M1 and M2 has different signs. M1 will be negative, M2 will be positive. M1 is the smallest value, M2 is the biggest value. In the first case, M1 and M2, both of them are positive. M1 is still the smallest value, M2 still the biggest value. We have a third case. You have a column without moment, but we have P ultimate. Hey guys, remember, we still have P ultimate here, we still have P ultimate. I'm talking about P ultimate behind or beside moment. P ultimate beside moment. In the third case, your column is long and we have P ultimate, but we don't have moment. For any reason, we don't have moment on this column. At this moment, we will talk about M2 will be M2 minimum value. We have a minimum value. You have to consider it. This value will be covered later today. So these three cases are very important. Please don't forget these cases. The first one, this moment, and this moment looks like this. So the buckle of this column will be like this, single curvature. In this case, M1 and M2, both of them are positive. M1 is the smallest value, M2 is the biggest value. Second column, we have moment looks like this. So the buckle of this column looks like this. In this case, M1 still positive. I'm sorry, M1 will be negative, M2 still positive, and M1 also the smallest value, M2 is the biggest value. If you have a column without moment, M1 equals 0, M2 equals 0, we have P ultimate, and this column is longer column, we still have M2 minimum. We can figure this out. But we have to design for minimum value. All of this stuff will be more clear, just wait a little bit. But until this moment, do you have any question? Okay, design of long column. We have few steps. First step, the factor design moment, M2, will be multiplied by delta. M2 will be multiplied by delta to magnify the value of moment. Because if you have a load P ultimate and you have buckling, this moment will be magnified, will be bigger. So ACI said, okay, I will use M2 by multiplied it by delta. Which M2? What is the value of M2? Okay, go back here. Do you have bending moment on the column like this? Yes, M2 will be the biggest value. Do you have bending moment diagram on the column like this? Yes, M2 will be the biggest value. I don't have moment. We still have M2 minimum. So M2 based on this case or this case or this case. I will multiply this value of M2 by delta. One of you will say, hey, I don't have moment, which is the third case. I don't have moment. In this case, which value of M2? Okay. The code provides an absolutely minimum value for M2 if you don't have it. How much? P ultimate time 0.6 plus 0.03 H. Here is the column. Here is B and here is H. So this length of the column is H. Multiply it by 0.03 plus 0.6. All of them times P ultimate. I can get minimum value for M2 if you are in this case. I'm talking right now about what ACI mentioned to take the effect of buckling. But just to keep in your mind, the effect of buckling is increasing, magnifying the value of moment. Buckling related to additional moment. So if you have a moment, please take the biggest value, which is M2, and multiply it by delta. I have question and I need answer. Anybody expect this delta, the value of delta, will be smaller than 1 or bigger than 1? What is your expectation? Remember, M2 is the applied moment, is the current moment. You need to increase this moment or decrease it due to the effect of buckling. What is the answer? Do you like to increase or decrease M2? If you understand this point, you can answer my question. Delta will be greater than 1 or smaller than 1? Any answer? Guys, delta times M2. Delta will be a value greater than 1 or smaller than 1? What do you think? Wow, smaller. Okay, one more time. If you have buckling, this buckling will do additional moment or not. The buckling effect will cause additional moment. That makes sense. Okay, so right now, without buckling, I'm not talking about without buckling, we have a column. This column has effect of moment M2. If you add buckling, the moment will increase or decrease. What do you think? Yeah, increase. So this is the moment on the column because it's a part of a frame or any reason. This is the moment on the column without effect of buckling. We need to add the effect of buckling. So I'm gonna multiply this moment by delta. So this delta will increase the value of moment to consider the effect of buckling. So I believe this delta must be greater than 1. That makes sense? Because this MC is a moment taking the original moment and the effect of buckling. So I expect this value to be bigger than this value. So delta will be greater than 1. Okay? If you don't have moment, if you have a column without any moment, okay, ACI said no, we have to consider a moment. So we have M minimum, this M minimum equal this value as a function of the applied load, P ultimate. Okay, what is the value of delta? Delta equal Cm divide 1 minus P ultimate divide 0.75 B critical. And this value for delta must be greater than or equal 1. So I believe I am good with this term, P ultimate. So I still need to figure out the value of Cm and the value of PC. Guys, do you remember, I'm not sure if you learned this before or not, buckling, P critical. Do you remember this term? I think in strength of material you should cover pi square EI over L buckling square. Do you remember something like this? Critical load? Critical buckling load? Probably. Yeah, critical load. Yes. Yeah. This P critical, which equal pi square EI divide L buckling square, is this term. There you go. BC equal pi square EI divide K L U equal L buckling length. How can I figure out the value of EI from this expression according to ACI equal 0.4 E concrete, Young's modulus of concrete, I gross moment of inertia for the column, divide 1 plus beta. This value is a ratio between the factored dead load and the total factored load. This relationship, beta equal 1.2 dead load divide P ultimate. Okay. Once you figured out the value of PC, so I am done with this denominator. I'm still looking for CM. Your value of CM will be 0.6 plus 0.4 M1 divide M2. Guys, don't forget, M1 is the smallest value. M2 is the biggest value. What is the sign, positive or negative, for M1 and M2 based on if you are in this condition or if you are in this condition? If you are in this condition, both of them are positive. If you are in this condition, M1 will be negative, M2 will be positive. One of you will ask me, if we don't have moment in this condition, M1 and M2 is 0, in this case, CM equal 1. In case of M1 and M2 are 0, which is the third case, take CM equal 1. We don't need to use this equation. So finally, I can figure out the value of delta. Finally, I can multiply this delta by M2. Finally, we have a column under the effect of P ultimate and M ultimate. This M ultimate is MC. How can I consider the buckling effect? I already did. How? During this moment. Because this moment is not the applied moment. This moment multiplied by delta to give you MC, which is M ultimate. Delta, consider the effect of buckling. Once you have a column under the effect of P ultimate and M ultimate, last step, I'm going to use interaction diagram. And we learned last time how to use interaction diagram. Wow. So if you are talking about long column, first step, I have to consider effect of buckling. How can I do this? We need to multiply the biggest value of moment, which is M2, times something called delta to figure out the value of MC. Once you are done with this expression and you figured out the value of delta, this moment MC, I can call it M ultimate. Beside P ultimate, I can use interaction diagram to figure out the value of rho and then the value of area steel. So the difference, the only difference between short column and the long column in case of using interaction diagram, short column, please, the given moment and the applied force as it is, or as they are. We don't need to make any change. But if your column is long, please, the moment will be multiplied first by delta to consider the effect of buckling. Once you did this moment, beside P ultimate, we can use interaction diagram to design the column. Any questions so far? Any questions so far? Okay, just a second. I'm so sorry. 1 minute. So guys, I'm back. Let's do an example. We have two examples. We have a tight column of the shown figure has been approximately sized to the dimension 12-inch times 15-inch. So the dimension of this column is given 12-inch and 15. It is to be used in a frame braced against sideways. The column is bent in a single curvature. Wow, this information is given. So this column has a moment here, how much? 86. And it has a moment here, how much? 86 given. So can you tell me which one is M1 and which one is M2? Okay, the biggest one is M2 and the smallest one is M1. You are lucky. Both of them are equal. So M1 will be 86, M2 will be 86. But if they are not equal, the smallest one for M1, the biggest one for M2. One more thing. Do you think M1 and M2, which one is positive and which one is negative? The problem said this. This column will buckle in single curvature. If you are talking about single curvature, both of them will be positive. This is the first thing. So we have M1, we have M2, we have P ultimate equal 110 kips. My question is, do you think this column is long column or short column? I'm not sure. The problem didn't say this. If you go back to the problem and read it carefully, the problem said tight column. But tight column, tight long column or short column, it's not given. Why? Because it's very important. If this column is short, so we have P ultimate and this moment, go ahead and use interaction diagram. You are done. That's it. Your P ultimate will be 110, M ultimate will be 86. Go ahead and use interaction diagram and you are done. If this column is short, you are in this case. That's right. But if this column is long, no, please wait a moment. We need to adjust this M2 to figure out the effect of buckling, and then we will use interaction diagram. That makes sense? That makes sense, guys. It's very important. You have a column, and we don't know if this column is short or long. Because if this column is short, and we have P ultimate and M ultimate, go ahead and use interaction diagram directly. But if this column is long, we need to adjust this moment to consider the effect of buckling. Thank you, Oliver. Yes, this is what should I do. Okay, let's do it. We need to figure out the value of K, L, unsupported divide R. Please read the problem carefully. The unsupported length for this column, LU, is 16 feet. And the K, to consider this end condition and this end condition is given. Okay, 0.83. Or we have three options to figure out the value of R. Probably this one, probably this one. I will not use this one because this one for circular column. More easy, I'm gonna use this one, 0.3 times H. 0.3 times 15. But we have issue here. L ultimate in feet, so I have to multiply it by 12 to be an inch, because the denominator is in inch, 15 inch. This value will be how much? 35.4. What is the second? What is the other value? 34 minus 12, M1 divide M2. Okay, let's do it. 34 minus 12, M1 divide M2 equal 34 minus 12. What is the value of M1? What is the value of M2? What is the sign of these values? Positive 86 divide positive 86. And you learn it. How can I figure out the value of M1 and M2? And how can I figure out the sign of these values? Single curvature or double curvature? I believe this value will be 22. Yeah, 22. So what is the case right now? K LU divide R greater than 34 minus 12 M1 divide M2. This one is greater than. If this one smaller, buckling is not considered. But this one is greater. So this column is long column. So we need to adjust this M2 first to consider the effect of buckling, and then we can use interaction diagram. Any question so far? Looks good. Looks good. Step by step. Step by step. Okay, let's consider the effect of buckling. Effect of buckling is very simple. Just M2 will be multiplied by delta to get MC. What is the value of M2? 86. Hip, foot. What is the value of delta? Equal CM divide 1 minus P ultimate, I think, divide 0.75 PC, I believe. That's right. PM minus divide 1 minus. That's correct. Don't forget, P ultimate is given. How much? I think 110 kip. So we're still looking for BC and CM. Okay, let's do CM. Very easy. CM equal 0.6 plus 0.4 M1 divide M2. So 0.6 plus 0.4. Please be careful about what is the value and the sign of M1? 86. What is the value and the sign of M2? 86. So what is the value here? It will be 1. Any question so far? Any questions so far? Okay. So CM equal 1. That's fine. We're still looking for BC, critical load. BC equal pi square EI divide K LU, all of them square. K is given. LU is given, so the denominator is not a big issue. Pi square is a number. EI, if you go back to the steps, EI equal 0.4 E concrete I gross divide 1 plus beta. 0.4 E concrete I gross divide 1 plus beta. What is the value of E concrete? Do you remember? 75,000 square root F prime C. If you open the problem, what is the value of F prime C? 4,000. The value is 4,000. So, square root for 4,000 times 75,000, this value will be 36,04996 PSI. The I gross for this column will be 12 times 15 cube over 12. This column parallel time perpendicular cube, which is PH cube divide 12. This value 12 times 15 cube divide 12 will be 3375 inch to 4. Beta equal 1.2 dead load divide P ultimate. Value of B ultimate is 110 keb. Please go back and read the problem carefully. The problem gives you, note also that the unfactored dead load equal 30 keb. So this dead load is 30. Multiply it by 1.2 dead load, and divide it by P ultimate 110. I can figure out the value of beta. This one will be 0.33. So EI will be 0.4 times this value of E concrete time this value of moment of inertia, divide 1 plus 0.33. So I can figure out the value of EI will be 3.67 times 10 to the power 6. So P critical will be pi square times EI, which is this number, divide K L 0.83, I think, L unsupported length 16. I will multiply it by 12 to be in inch. This one in feet, 12 for inch square. The value of P critical will be 1,426 kip. So this value for P critical 1,426. This one is okay. This one is good. This one is good. I can figure out the value of delta. Your value of delta will be 1.1. So MC, which equal delta M2, will be 1.1. M2 86. So your value will be 94.6 kib foot. So finally, we have P ultimate equal 110 kib, and we have M ultimate equal 94.6 kib foot, and we have a column with dimension 15 inch times 12 inch. Can use interaction diagram to figure out the value of rho. From here, we are starting a new problem. How to use interaction diagram. P ultimate is given, M ultimate is given, and the column is given. One of you will ask me a question. Where is the effect of buckling? Okay, the applied moment on this column was 86. After we consider the effect of column, we will design this column under the effect of 94.6. Why you increased the value of moment? Because I consider the effect of buckling. That makes sense? That makes sense? Okay, looks good. I'm gonna do the second example next time. Second example exactly the same like the first one. Nothing changed. Everything the same. Okay, let's do it next time and do some review on Wednesday.
So, Dr. Ammon?
Yeah.
Do we stop to where we get to the use?
No. Don't stop. Please go ahead and solve using interaction diagram. What is the value of Rn? What is the value of Kn? And figure out which interaction diagram I'm gonna use. Put this value and this value to figure out the value of rho, and tell me what is the area steel, and tell me this area steel how many bars and what is the size. And don't forget this number must be even number. No, you have to continue.
Right. Okay.
It's a long problem, but it's very easy.
Thank you.
Very easy. And please make sure you can figure out these values correctly. What is the value of M1, the smallest value? What is the value of M2, the biggest one? Which sign, positive or negative, based on is it single curvature or double curvature? Or you can watch this moment and this moment will make this column to buckle like this. That makes sense. So it's single curvature. Both of them will be positive. Sometimes we have different cases. This is the first case, single curvature. Second one, probably we have double curvature. So we have one of them will be negative, one of them will be positive. But we still, M1 is the smallest one and M2 is the biggest one. Okay?